Organic molecular structures. Introduction to organic molecular structures. Organic chemistry can be considered to be the chemistry of carbon compounds. Together with carbon, hydrogen is present in most organic compounds. These substances are called hydrocarbons. Organic compounds can also contain other elements along with carbon, such as oxygen, nitrogen, chlorine and bromine. Carbon is the basic building block of organic compounds. Carbon recycles through the Earth's atmosphere, water, soil and living organisms, including human beings through the carbon cycle. Carbon is present in our bodies in the form of proteins, carbohydrates and fatty acids, whilst carbon is also present in other organic substances such as petrol and plastic. There are millions of different organic materials and substances on Earth. The reason for this is because of carbon's unique bonding capabilities. Carbon has the unique characteristic among all elements to form long chains of its own atoms, a property called catenation. It is able to form very long chains of carbon atoms, as well as branches and rings. Some factors which make carbon bonds unique include the fact that the covalent bond between two carbon atoms is quite strong. Carbon compounds are not extremely reactive under ordinary conditions. A wide variety of carbon compounds are possible since carbon can form up to 4 single covalent bonds. The ability of carbon to make bonds with itself, a process known as catenation. The ability of carbon to make multiple bonds with itself. Organic compounds can be represented in different ways. You need to know the following methods of representation. Molecular formula, e.g. C4H10. This is the simplest method of representing an organic substance. It only shows how many atoms of each element there are within the molecule, but it gives us no indication as to where the atoms are found in relation to one another. Structural formula, e.g. This method shows us exactly where each atom within the molecule is found. Condensed structural formula, e.g. CH3CH2CH2CH3. This method lists the carbon atoms in the molecule individually and shows how many hydrogen atoms are connected to each carbon atom without showing the bonds. We will study organic compounds that are grouped together, as they have similar characteristics and properties. It is necessary to classify the millions of organic compounds that exist in some way. We do this by identifying the functional group and homologous series of the compound. The functional group of a compound is an atom or a group of atoms that form the center of chemical activity in the molecule. A homologous series is a series of similar compounds which have the same functional group and whose consecutive members differ by CH2 in their molecular formula. All compounds in the same homologous series obey the same general formula. The functional group of a compound assists us in identifying to which homologous series an organic molecule belongs. Science around us. Rock paintings. Charcoal, which consists mostly of carbon, was used by the San people to mix black paints used in rock paintings. Alkanes. The alkanes are a homologous series of hydrocarbons where the molecules are characterized by single bonds between their carbon atoms. Alkanes are said to be saturated compounds. A saturated organic compound is one that only contains single bonds attached to carbon atoms that make up the compound, as this indicates that all the carbon atoms within the molecule are connected by single bonds. Alkanes have the general formula CnH2n+2. The general formula can be used to determine how many hydrogen atoms an alkane molecule will contain, if the number of carbon atoms within the molecule is known. For example, if the alkane contains 3 carbon atoms, then N equals 3. If N equals 3, then the number of hydrogen atoms within the molecule will be 2. 3 plus 2 equals 8. Therefore the molecular formula of the compound will be C3H8. The name of the alkane is determined by the number of carbon atoms it contains in the molecule. The number of carbon atoms in the molecule determines the prefix of the name. Alkane molecules' names will always end with the suffix -ane.